So this stuff was all about placing random things on modules, whatever size they are, and later we added an optimization. Let me find this wall. We added an optimization that we can use interactive refresh, sure, like this. And we can also disable that for performance and only refresh the wall on the click of a button, okay? So that was it. That we edit something and then refresh. Thanks to this, it's much more responsive, especially you could see the problem if you used, for example, interactive refresh on everything and had a lot of walls to move. Let me hide the ceiling. If we had a lot of walls to move and we had interactive refresh, then you can see how it slows down. It slows down to a crawl. So this is why we introduced this button. Hey Piatnashkin. Today I tried to do what you suggested last time, which is spawning modules in the local space and only then transforming. I will try that later on this stream. Yeah, because last time the problem was that all these transformations, when they were stacked up, then rotating was a huge problem, for example. Basically the typical order of transformations issue. So yeah, we found a workaround last time, but it was not ideal. Let me find this blueprint. So today I'll try raycasting these things towards the module in the module space and only then rotating. That's the plan. Quick recap, what is it all about? It is about being able to move a point and having the wall scale. Here it doesn't work because the module is rotated the wrong way, but in general it should fit. I don't know if I have this original mesh here. What was it? This maybe? Oh, I can't change. What? Yeah, anyway, the whole thing was about finding the size of a module and making it fit together with the number being what we need to reach the given length. Yeah. So as you can see, this is a module, like so, very short, and it's copied seamlessly, each module touching the next one. And then 3 or more decorations, yeah, 3 meshes, but it can be however much we want, are spawned on each module. Currently the number was hard-coded to 8. So how it looks like. Construction script is very simple. If using interactive refresh, refresh wall. This wall generation contains everything and it has call-in editor enabled. Call-in editor is enabled, exposing this button refresh wall generation. The same name as the function. This way we can either click or make it refresh itself on construction script, which is called whenever something is moved. There was also a nice suggestion yesterday, but I have to find it. Yeah. In class settings, there is run construction script on drag. So if you don't want to put the whole effort of packing everything into a function and a button, but still you need a lighter construction script, you can disable run construction script on drag, then it won't refresh itself when moving the object, only when changing something else, like variables. So this is also an option. I will leave it here, because we have the button and the switch. What's inside? Inside is a sequence of everything also packed into nice functions for readability. So first it has to clear, because it adds modules, so when it refreshes itself, it has to delete whatever there was previously. So clear sets a random seed again for randomization, destroys its every child, clears instances when the children, like wall and connectors, the pillars, are instance static mesh, and that's it. Clears everything. Next function here. Wait a second. Initialize. So basically, every setting that can be pre-calculated once, like the mesh length and so on, it's pre-calculated once in the initialize function, and then stored into variables. This actually also can go to initialize, so let's move it there, like so. Sequence. Yeah, so it sets the mesh of the module and the connector from whatever the user set in the variable. It's doing it here for the instance static meshes, and then calculates the length of said module and the distance towards the point, towards the vector. The point is the thing, last instance end, here, and it's basically a variable here with show 3D widget enabled. So this exposes this gizmo that you can see here. So this is initialize. Let me remove unused pins. Like so. Okay. Next thing. It calculates how many instances do we need and how to scale the module so that the total instances match the desired length to this point perfectly. Piatnashkin says that we can also run destroy component on arrays of components. So do you mean that in clear I could do this, I could take this decorations array and do destroy component? Destroy component. No, I think I can't, because if I try... Oh! Like this? Does it work? That sounds pretty neat if it does. This way I won't have to do this reverse for each loop, because reverse loop was to delete them so that the loop order doesn't change while we do so. Let's try. Save. Oh, it won't compile. Distance to end could not be found. Oh my, because it's a local variable. Local in here? Yes. Can I make them global? Somehow? Promote them? Ah. Okay. Distance to end. Okay. So I have to delete them here. Oh, why is it so painful? Distance to end. Can I really promote them to variables? By drag? Ah, whatever. Underscore. Is this used? No. Is this used? Yes. Okay. Nope. Yes. Okay. Match them. Scale to match. And cool. Now I'll replace them like so. setting this instead. Okay. Here as well. I should make something more readable. Basically what I'm now doing is replacing local variables with global, so I can pack more stuff into functions. Cool. Cool. Now initialize can set this instead. These global ones. Okay. Okay. Now I'm sure there were more uses of these. Find. No. Find. Nope. Okay, no. Cool. I can delete them. Perfect. Let's try if destroying an entire array works. It was in clear. I can get rid of the loop and just destroy an array of components. Like this. Let's try. Yeah, I think it works. Thanks, Piatnashkin. Very nice. So we avoided a full loop, manual loop, by just doing destroy component on a full array of components. Very good. It's a general syntax. Okay. Very interesting. Very interesting. Probably this way is also a ton faster than Blueprint, because iteration over loops in Blueprint is slow. Okay, so we have this, and this is the part that we'll clean today. Add module. What it did was adding a new instance to the instance mesh of the wall and moving it and rotating and everything at the same time. And only then we had add decorations, which took the transform of this module and tried to place decorations on it, which, as Piatnashkin said, is bad, because we'd be much better off placing everything in the origin and only then moving them together. With the exception of scale, because we don't want to scale the decorations, but we do want to scale the module. So these are the decorations. They were getting the bounds of the module, randomizing up to 9 points, decorations count, picking random mesh within the array of meshes that we provide, getting a matching local rotation so that we can specify rotation per mesh, and then putting it on the wall. Get random point within module. And there was also one thing that we added last time, anti-decoration volumes. There are volumes in the scene, like this, that prevent any decoration from spawning. Let me show this. These green boxes. These are just trigger volumes that we utilized for this occasion. As you can see, when we move the module, decorations disappear if they are within this volume. Like this. Of course, the volume is not a part of this construction script, so it doesn't react automatically, but when we move the module, the blueprint itself, it does. Like so. Anti-decoration volumes. So this is the part that we will keep, but the transform is what we will clean. So what we need to add a decoration. Yeah, volume in Unreal Engine 4 always have great names. Like my favorite, Kill Z volume. Where was it? Yeah, pain causing volume. Kill Z volume. They are beautiful. Beautiful. Yeah, to add our own, we have to do C++, and we don't want to do that here. So let's utilize one of the existing ones. Okay. There's also a floor that I quickly assembled from the nanite meshes. But what we may try is actually doing a material that will do seamless tiled floor automatically, like planar mapping. This is for later. But these are also nice because they are sculpted. But I think with parallax occlusion or normal mapping we could have the same. Okay. Okay, so allow me to take some time to refactor this thing. We'll try, basically let me take a screenshot. And we will try, I will try spawning some random points, like so, that will be, they will be offset from the wall. Okay. And what I try to do is to cast rays towards this wall, towards the wall, and upon hitting surface, I will place the decoration there. Therefore, getting rid of this whole pain with checking the mesh's extents at the cost of some more computation, but not that much. This module is simple, so maybe it looks like it doesn't need that, but I can show you another one. Let me use that thing. Docking layout. Mega scans. There was medieval wall. There was a wall. But where are the thumbnails? Oh, not here? Here. Take a look. If I used module like that, oh, now it matches the end because it's the correct rotation. And let me show you. See? It picks how many modules it needs, and it perfectly fits this point. This previous mesh didn't work because it was rotated. It didn't have pivot in the right place. Okay, like this. So this mesh, as you can see, can cause problems. Problems like this. We can also, if we had ray tracing, we could also check if it comes through. If it comes through and leaves the bounds of this mesh, then we can safely assume we don't want to place a decoration there. Okay? Hi Denlandish. Let me post a link to the stream, by the way, to Discord, and here a link to Discord. Give me a second. Okay, Discord. Come join us. Here it is. If someone's not there yet, you're very welcome. And in the meantime, I also post that I have the stream. Give me a moment. There. Hi Birdshot. Cool to hear that you had time today. So yeah, super quick recap for those who joined. We'll try to place decorations this time on much harder case than previously. Because previously we're finding the bounds of the mesh and placing them like on the extents of this mesh. But here it doesn't work because this mesh is heavily varied when it comes to depth. So we'll do the raycasting for that. Hi Jeffrey, how are you? I hope you had a good week. What are you guys doing the last week? Have you had time to catch up with Unreal Engine 5? Or basically anything in Unreal? Or you were focused on something totally else? Let me know, and in the meantime I'll spend some time refactoring this thing so that we do it in module space. So I guess that add decorations should go inside add module this time, but we'll see. Basically add module shouldn't transform it yet. It shouldn't add transformation at the beginning. Where does connector transform come from? Does it come from the arguments? No. Connector. It's just the transform. Okay. It's just local thing. Bartshut says that the noise I have is due to the objects being small. This noise, this flickering. I know, thank you. This is due to how Lumen works. It basically can't take as many samples as it would like to because of, real-time performance implications. So it's quite crude when it comes to sampling. And with big scale, it's okay because many samples hit the sky. It's very smooth. But for tiny objects like this, it results in noise. Let me go to lighting only. Now the lumen doesn't work. What? How to view it? Detail lighting? Yeah. Yeah, you can see the flickering. You can see the flickering. This is because of the not sufficient amount of samples to cover such very small but very bright surface. For the sky, light is very okay because it's smooth and big. Right? Let me bring back the ceiling. Yeah. So you can see the flicker. You can see the flicker, how it tries to take light from these small sources. While the sky, the big source, is perfectly fine and stable. Dim candle effect, exactly. We can assume these are candles moved by the wind and everything's fine. No, later we'll replace them with basically lamps placed instead of this. But for now, let's keep them. Oh, Jeffrey says they started learning Python for work and hopefully catching up with streams this week. Hi Starpony, how are you? Other Twitch forgot to notify you? Does it happen to anybody else? Because I heard something like that, that Twitch can sometimes not notify people, even if they had this bell icon enabled. But please check that you have this bell icon on Twitch enabled on my profile. But if it happens to more of you, then let me know. So let's try moving everything to module space. For now, it won't scale nicely, but it's okay. It's just to refactor, and in the meantime I'll hide the scene. Cool. It didn't notify you. Okay, give me a second, guys. Give me a moment. Twitch TV. So, when you go to Twitch TV/. slash techard8. It's not here. But anyway, you have follow and you have notify. So both would have to be enabled. Thanks for following. Nice to see you here. Lander says the Twitch spams them with email. Hi Bazari, thanks for following. Okay, so guys, that's even another reason to join Discord. Tomek Badaniecki, hey, how are you? Join Discord, guys, and then I will notify you on the streams and tutorial channel on Discord that I'm going live, because it seems that Twitch has some trouble letting you know that I'm live. I've also heard about it, so very unfortunate, but yeah, at least we have Discord. Okay, let's move everything first to the module space. So instead of this nice transformation, which is very nice, but for later, I will delete that. Connector transform, do I want it? Yes, I guess. Okay. For the connector, instead... whatever for now. Whatever for now. I will just scale this. So basically now I'm refactoring, so expect that it will work worse for a moment until we clean it up. In add module, I will just add an instance of the module, instance of the connector, which is this pillar here. And then I return the index of both. Instance index. Instance index comes from what? From the loop, okay. So it's just a pass-through. Alright. And it doesn't compile because there's no transform. Then just use the default one. What? I have to make an identity? Like this? Okay. Split pin. This pin? Like break? Okay, cool. Nice tip. Thanks. Splitting the pin makes it not complain about there being not a default transfer. Cool. Yeah, and then return. Actually, we may make it like so. Now everything should fall, yeah, into one piece. This is very good, of course. Let me disable others for a moment so that it works faster. Hide them. Wait, except for, God. Except for this. Cool. Very cool. What's there? Okay, let me bring that back so that only one module is needed. Perfect. We have this. I will now... What do I need to do? I need to find these random points. So add decorations, sure. But I would like to do it inside of this, I think. To be able to move them together. Yeah. I take it from here. inside. We need a sequence again. So this is just a pass through. I don't know if it's needed, but okay, whatever. And now I would like to add decorations, and these decorations should be added into some kind of an array. So let me return this newly added decoration, wherever it is, static mesh. It's adding it to spawn decorations, sure. But I also want to return it. Where is return? There isn't. Oh my, this is so messy. Return. And I want to return this stuff. So basically I want to keep track of the mesh so that I can move it later together with the module. Let's keep it messy like spaghetti for a while and we'll clean it up later. Basically it adds a decoration mesh and then returns it like new decoration component. Cool. Okay, so now it adds this. And is it in a loop? Yes. So we should add that to some local variable called new decoration components. It will be a static mesh array, static mesh component array. As I said before, it shouldn't be static meshes, it should be some kind of instancing, but for the case of this, let's not complicate it, okay? Array. Yes. So I'm just adding static meshes, it's not optimal, but it's alright for now. Add. So I'm collecting these newly added decorations per module into an array, and I will return it to be able to transform them later together with the module. There is no return node again, so return like this. New decoration components like this. What? Oh my. Cool. Now going back to add module. It's adding decorations and it's returning an array of references to decoration components, which is perfect. For now, we'd like to skip the module transform at all. So I'll be removing this, I think. Remove this. How can I remove this? What? How to delete input variables in Unreal Engine 5? What's going on? Wait a second. How to do it? I have it here. I want to remove this input. And now what? There is no delete. There's no drag. From inside? Yes, from inside. Okay, maybe from outside, maybe from this. When I click this add decorations, no. There is no X button. When I open it, class defaults, nothing. No. No class setting, I want properties. Add decorations, and I want to get rid of this. How to do it? What? Okay, never mind, never mind. Instance index, is it needed? Is it used? No, it's not. We can get rid of this, I think. Instance index is not needed. Oh, and again, I can't delete that. Okay, whatever. Not used. So if instance index is not used and transform is not used, if I... Nah. Want it when you click on the input node here? No. There's also no delete. Nope. And also when clicking on a function at decorations, there's also no X to kill them. I don't know. Whatever. Or maybe someone had this problem. UE5 delete input pin. Function. Nope, nothing. We are missing something obvious, or UE5 is missing something obvious, I don't know. I don't know. Okay. Getting the bounds of the mesh. Okay, sure. But then picking a random mesh is fine. Finding the rotation is okay. Then there's get random point within module. Okay, I will delete them. Yeah, I will rename them. This to delete 1, to delete 2. Okay. Maybe delete when the mouse is over. No, unfortunately. Nope. Alt click, Ctrl click, no. Oh. Unfortunately. But yeah, this is good. To delete. Okay, get random point within module. Module transform also isn't used now, I think. Oh, it is. Yeah, and we don't want that. We don't want that. We just want a random point within bounds. It's all right. And then the Y. Oh, sorry. And then the Y will be just some big number, okay? So we have this thing, but do we have the module? We don't. Ah, there is module mesh. There is module mesh, but there is... But how can I... Because it's an instanced mesh. So I would have to test against the instancer, I think. Let's try. Instance group wall. Trace line trace component. Yeah, tracing against the instanced wall here. There is the bounds of this mesh that we used to copy this. We're getting its extents. Getting random position. This is not needed because this was to make it appear on the surface. So this is not needed, this getting bounds. Or maybe it is. Actually, maybe it is. We may multiply this. Multiply. Or do we want it? Maybe not. Maybe not. Okay. I'm getting a random point in X and Z. Modulus X, Z bounds. Then applying a big Y offset. Okay, so this offset will be literal float offset from the mesh where ray tracing starts. Cool. And the offset will be, for now, let's say 5 meters. We may adjust it later, but for now it's clever enough, I'd say. It's not clever, but it's clever enough. We have this LineTrace component. It works in word space, I think. So we'd have to transform location using the get actor transform of this current blueprint, moving this location inside the mesh bounds. This thing. Ah, wait, it was needed. This was needed, this bounds, sorry. Because we need it was within the meshes, yeah. It was within the meshes bounds. It was like basically -1 to 1, like this. And the same here. -1, 1. And then it was scaled by the mesh size. Okay? Relative bounding box position, exactly. A position relative to the bounding box. So this was it. It was lower than maximum so that it doesn't touch the edges. Relative to bounding box. Okay. With margin. With custom margin. Okay. And then it was multiplied by the size of this mesh. So get the mesh again. Get extents. No, get bounds. Break. It was wait. It was multiplied by extents, and then an origin was added to it, I think. Like so. So this should be called... Okay, so here... relative to B-box. So if it is, let's say 2, then it's good enough now, because it was scaled by whatever the size of the mesh is, so even better. It will be very universal. Let's move it here. Oh, come on. Yeah. Wait, let's store it in a local variable. We will call that random point bbox relative. Okay. And now I can get it here. I can get it here. So we have this point. We're scaling it to match the size of the mesh. That's good. And this will be stored in a local variable called random position local. Local meaning local to the actor. Local to the actor, the entire blueprint. Because we are taking no, to the mesh. Wait, to the mesh. But it's the same because the module is in 0. And now this will be world. So location is this. Random position. It will be random position where. Okay. If we have this, then now we can cast a ray towards this module. One thing. So instead of that being Y, I could actually add this, or maybe no. Maybe Y is okay. Y is okay. I was thinking about the forward vector, but why bother? Now the only thing to do is to calculate the end of this thing. So this is random position word. Sure. Now we should also take... Hi Legomir, how are you? How was your week? Get forward vector, I think. Forward is Y? Yeah. Okay. So I'm getting this position randomized. Let's print them. Let's basically print them. So debug draw sphere. Here, duration, I don't know, 2 seconds. Smaller radius, like so. Let's check what we have. Oh, blueprint bad. Blueprint bad. Bad blueprint. Invalid transform. Sure, because I wanted to delete that, so I don't care. Okay. Transform and let's name it. I don't use it, right? No. To delete 1. Only real forward vector is Z, not in this engine, man, not in this engine. Z is up. Like in every normal software, namely Unreal Engine and Blender, the only ones that do it. And Red Engine. Here we have... I don't want to add this mesh for now, so let's break this next pin. Let's break it for now. I only want to display these random positions. Yeah, they're good. They're here. Are they offset from the surface? Yeah, they kind of are. That's good. From these points, I want to track towards this side, okay? So let me first, also as a debug, draw a debug arrow from this to the end. So my forward vector will be multiplied. Wait, get random position. Get mesh bounds. I also want to get bounds of this mesh. Break. I also want to get y size of this mesh. Multiplied by the forward vector. And a couple times more because... Wait, these are the extent. So extent is half of the size of the mesh. So I want to multiply it at least, let's say 4 times to make sure it goes the whole way through. So multiply by 4, then multiply the forward vector by this. Wait. Float. No, multiply. Oh, come on. What's going on? Can't I just multiply this by this? Okay, whatever. And this should be my end rotation. So same point, but moved forward through the mesh to the other side. Let's try drawing a debug arrow. Draw debug arrow from this point to this point. Arrow size, I don't know what it is and in what units. Duration 3. Oh, that's pretty bad. They are pointing somewhere. And it seems that hiding this didn't prevent their recalculation, so let me just delete them for now. Like so. Cool. So again, this was bad. Oh, other. Thanks for the chart that compares the coordinate systems between the engines. Y up in most of the stuff, Z up in quite a lot. 3ds Max, Blender, CryEngine. There is one thing missing here, guys. There is one thing missing in this chart. Very important for my daily life right now. Right here, we should have okay. The others don't matter. This one is Z up. So that's it. Let's go back to Unreal and come draw some arrows. They are pointing there, probably towards the scene 0. That's because I just calculated just the forward vector, but I didn't add the original thing. So plus this. I want offset from this point, like so. Maybe no. Where they are pointing? The thickness is 0. Okay, wait. They're pointing there. They're pointing there. So we don't want forward, we want get side vector, right vector. Oh, come on, get actor right vector. Let's try. Okay, cool. Okay, cool. Right vector, but inverse. So times -4. Perfect. Perfect. And this will be called get vector pointing towards through the mesh module. The module mesh. Okay. Get word space vector pointing towards or through the mesh. Okay, so now if we rotate this, it should also point to the right direction, as you can see. So that's good. And now we can actually trace against it. Let's trace against that. LineTrace component, okay? So instead of drawing the sphere at the origin, I would like to draw it where the arrow has hit the surface. Let me show this. First, I will store this position into like a variable. So like array destination world. Okay. Going through here. Cool. I want to now. Let me zoom into this because I know, guys, that this is very small. What I'm doing now, I had this local position, I had this now word start and word end. Let's name it array start world and array destination world, trace start, trace end. So exactly what we have. Word space start, word space end. We also have show trace. Show trace. When I compile, okay, it's very short, very persistent. Cool. So you can see the trace is being cast against this surface, but it didn't hit anything, and that's worrying. And that's maybe it can't trace on itself. Maybe it can. That'll be bad. But I'm tracing this component, so instance group wall trace complex means whether it should just trace, like if it's off, it should only trace against physics, against collision. When it's on, it traces against graphics. So the whole triangular mesh. Maybe I should disable that. Wait, maybe it's good because they're orange. I don't know. No, this is orange too. Let's try hit location and draw a debug sphere there. If it draws it in the end, it means it didn't hit anything. Oh, even worse, it doesn't draw. It doesn't draw. Or maybe it draws in the middle of the scene. Yep, 0. Oh, that's bad. That's bad because it means that the traces didn't hit. They went through, they didn't detect this component. So this is 0. Return value, we can check that. We can select the color. If it hit anything, basically you can break out hit. If it was a blocking hit, then pick A. So green, it hit anything. If it didn't, draw the sphere red. Like so. Like so. And let's see. Yep, it draws them red. Meaning these traces didn't hit any surface. Which is very bad for us, because I was trying to, you know, trace against these already spawned modules. There is refresh mode generation, there is add module, it adds an instance and only then it adds decorations. So I hoped it would be already there, but seemingly it's not. Legomi asks if tracing on itself wouldn't be bad performance-wise. It shouldn't be. It shouldn't be, because, you know, it's doing everything in steps. So once the module is spawned, I shouldn't care whether it's in the Word or whether it's in my own blueprint. You cannot use bbox and other things for speed up. Yeah, maybe. Maybe this is about constructing the actual physics representation, like the, how is it called? You know, this kind of stuff like octree, that the representation of the scene but simplified to check where the rays can hit anything. Yeah, the physical proxy of the scene. Maybe that's that. But that's very unlucky. It means that you would have to do decorations on another actor. Or maybe Nanite doesn't use complex collision at all. Let's disable Nanite on this mesh for now. Use Nanite, disable. Cool. Nope. Still nothing. LineTrace component, but then why would we have something like LineTrace component? But yeah, it may be like this. How can we work around that? Component is instance static mesh, that's good. Wait, if I just did LineTrace by profile or channel? Profile. No, by channel. LineTrace by channel. Visibility camera. Wait, there was another. There was LineTrace by object types. Object types, yeah. Make an array of word static. Cool. Let's try this. With same stuff. Trace complex, yes. Ignore self. Oh, it's not there. Okay, ignore self, no. Sure. And now draw my debug sphere. Out hit break. and the center out hit location. Now it's good. Okay, so it's possible. Line trace for objects without ignore self, and the object types is an array of just one element, word static. And now they hit. They actually do. This won't be needed anymore. They are persistent, so I have to delete this object. Uh-oh. What? I have to restart the map or what? To clear this? Okay, I will restart the map. Good. Yeah, so it's that. That's that. We have to line trace for objects. That's fortunate. Ignoring yourself is very toxic, says Legomerston. Definitely is. Don't do that, guys. Take care of yourselves, especially during this pandemic. Ignore self has to be disabled. And yeah. Do we have it? We have it. I will delete the ceiling. Now we can place the actual decorations, but it also means that I would like to ignore... Because you know, we do this here, but when we add these decorations, I would like to gather the points and only then add the decorations. Otherwise the traces can hit other decorations, okay? So yeah, then return. So I should return the hit location. Debug is out. I would like to return the hit location. So let's do the property variable. One thing guys, if it didn't hit anything, this point should be discarded. So we should make a local variable called success. It should be of type boolean, single, and success if it was a blocking hit. So if it hit a surface, and then the location, it would be final location on surface word set. Okay, and now it should return whether location word this, and it should return whether it was a success or not. To delete to boolean success has hit surface. Okay. And success. Cool. Because we don't want to do anything if this won't hit, if it was, you know, through the window. Okay, so we have this function. This will be trace towards the module mesh. To find position on surface and return. And this was transform the position into module space in meters, in centimeters. Now let's go back to our add decorations where all this happens. So as I said, we don't want to add the decoration instantly because next decorations should still be able to hit the surface of the module instead of other decorations. So I'm getting a random point within module. I will store that in local variable new decoration locations. Word. Not word, not word. Just locations. Vector. Cool. I'm getting random point within module. Here it is. And now this will be an array. And now actually it should be the first thing I do, not the last. It should be the first. Let's get this here. So the first thing I do is getting this random point, and I want to transform this location back to this actor's space. So get actor transform inverse transform, I think, location, this, if it was a success. So branch, yeah, only if it was a success. I want to transform this and add it to new decoration locations, I guess. Add that. Cool. So this should happen in a loop. That's good. Now, when the loop is completed, I want to start another loop, but this time over this. So get length -1 for loop, like so. So we aim to get 9 decorations per module, but we end up with less if some of them hit the window. Of course, you can decide that, for example, you want to redo the randomization. That's also cool, but I would do it like that. Let's just lose them, throw them away if they hit the wind. Cool. This is not needed for now, like totally. Another sequence, loop body, sequence. I detach this for now. I don't care yet. Okay, here I'm then gathering these transforms, getting random points, and then for every point that was found, wait, does for each loop also provide the index? It does. Okay, so let's use this. For each loop, it also gives us the index of the location. That's fine. For every one of them, let us add an instance now. So Legomir asks if I ever used access I with eyes, a soft image. No, I didn't, unfortunately. I heard it was powerful, kind of like Houdini stuff, but I didn't have a chance. But you know, the concept of creating geometry with nodes is a huge one, and you can see how Blender has evolved recently. Let me show you something quickly. Twitter.com, record date. There was this liked things. What? I've posted something recently. Give me a moment. Among all the stuff that I liked. Or maybe I retweeted this. Oh, this. Take a look. Oops. So Camertone made this thing in Blender. In Blender, using Blender's geometry nodes, which are kind of mini Houdini, like Blendini. See how nice it is. And works fast. It works quite fast, and the result is just beautiful. So geometry nodes in Blender, recent release. Be sure to get the very latest version of Blender because they improved them a lot. Blender is Houdini now. Not yet, Piatnashkin, because Blender is nice. Geometry nodes are very powerful, but Houdini has the correct underlying structure. The Unix-like paths. The glob, which is the asterisk, working everywhere. A very coherent structure where in Houdini everything is an attribute, either on point, primitive, or vertex. And that's it. Everything from flip fluids or volume. So from flip fluids to smoke to volumes to meshes, everything is using the same structure of these 4 basic primitives. So you can sample a volume, spawn something there. You know, you can read fluids like points. So yeah, Houdini has the great concept underneath, which paradoxically made it survive to the modern times, when it turned out that an approach like this is very important. Blender has to emulate this with nodes, and you know, you have to drag pins like in Unreal. Actually, they are very similar. So Blender, I'd say, is between Unreal's construction script and Houdini. But the heavy stuff I would only do in Houdini. Especially how you can, for example, replace a string inside to switch an object to another object. Yep, Houdini also adds modeling features, but I doubt they will be able to match like Blender's efficiency in that regard. But maybe, you know, maybe some level is enough for Houdini to be actually useful in that regard. They will swap eventually. Maybe, yeah. Maybe, yeah. What is it that I consider heavy? And Jeffrey, so heavy, I mean, not heavy in terms of computation, but mostly heavy when it comes to how much work I have to involve to be able to, for example, replace a part of a procedural setup. In Houdini, you can basically work on so many abstraction levels. You can put nodes into subnetworks. You can refer to everything, for example, by path, or place a small Python script inside the node network to, let's say, choose the proper module based on something. While in Blender, you'd have to, you know, the spaghetti grows quickly, kind of like it does here. But even here in construction script, we have a ton of nice arrays and local variables and everything. So yeah. So heavy for me is when I have to put a ton of work to change a small part, when it becomes very, you know, slow for me to work through it. I have to remember anything. I have to manually replace something. While Houdini, for example, has gone even wilder now. They were already very good, but now they also have PDG, which is like distributing of creating variants of an asset or tiles on a terrain among many threads or machines. So they have very powerful nodes that can, for example, read a CSV data table and configure stuff based on that, on your scene. Super powerful, hard to explain quickly, but let me find Simon Houdini. Simon Houdini. Simon Houdini here. Okay, great examples of Houdini. And yeah, so Simon made an environment. I don't know if it's here. Oh, it's not. Oh, it's here. Procedural desert tutorial. Be sure, guys, to check this out later. Basically, it's a scene where the terrain is refreshed in tiles, so the work goes in parallel on multiple cores, and it refreshes dynamically tile after tile after the given tile is finished. Amazing stuff. I really recommend this video. This is a short version, but somewhere there is a full version of that. I think here. Procedural desert. Yep. And it's also in Unreal with Houdini plugin. So this is what I consider complex, and I would prefer to do it in Houdini rather than in Blender. But for stuff like a single building with many decorations and artistic stuff, I think geometry nodes would be very powerful. And they will grow better with time, I believe. So yeah, let's see where this ends. Maybe this would be, great enough for many, many people. Not everything has to be a AAA production, right? Okay, so here, back to this. What I want to do. I want to spawn right now anything based on the locations that we traced on the surface. Okay? So for now, I get my spawn decorations. I would like to add a static mesh component with relative transform to this actor from here, and then I want to add this thing to my spawn decorations array so that I can clean this up later. Add unique this. Now the mesh doesn't use any mesh, so I would also have to do set static mesh. And set it from my currently let's just go with the first decoration mesh that I have here. So get 0, just as a preview, you know. Cool. Okay, these are lamps, so maybe get 1. Cool. So as you can see, they align to the surface. Of course not perfectly, because the pivot is inside, but it doesn't matter for now. I will add the manual offset later. They basically align with this stuff. Let me change the seed by moving this thing. Oh, the seed won't change. The seed was somewhere there. Random seed 2. Cool. Yeah. Actually, I can now make them spawn on the bottom as well. Get random point. Where was it? Get random point from minus 0.7 to 0.7. Okay. Yeah. Uh-oh. They still... Is there a window or something? Wait a second. No, there's not. Oh, I should make it nanite because it's quite slow. Nanite enable. Why did it spawn here? Honestly. Oh, because it spawned on the surface. Really? Yeah, seems so. Okay, whatever. Yeah, this is clearly a problem here. Because of the size of this decoration, basically. Because it can't decide what to do on the slope. What we can do is we can compare how bad is the normal, you know, compared to the actual forward vector. So let's go back here. Let's go back here. And there should be get random point within module. And we also have hit normal. Let's compare it with dot product. Yeah, if you've seen my math stream, that there was a piece about dot product. If you haven't, then on Gumroad I have Math Essentials, this thing which covers the dot product and how it works. So dot product here. Yeah, it compares a vector. So it compares our hit normal with how was it? Get side vector, get right vector. I want to check whether this normal is similar. So let me draw a debug sphere for 3 seconds and choose the color based on this dot result. So dot result is from -1 to 1. I want to remap it, map range clamp, from -1 to 1 to 0 to 1. Trusty old dot product. Yeah, I know, Legomri, that it projects one vector to another, but I want, you know, to talk about the practical usage of this. For this, it serves as a comparison of two vectors. Though I would have to... No, I won't have to normalize it. Okay, I'm remapping the result of dot product. -1 means it's totally opposite, 1 means it's the same. I will remap it from 0 to 1 and choose the color depending on this. So if it's the same, it will be green. If it's the opposite, it will be red. Anything in between, it will be in between. Okay, the center is location on the surface. Cool, let's try. They're here. Okay, so these ones apparently hit a very front-facing normal. A very front-facing normal. Let's try a different seed. The same? Oh no, here. Can you see? 6. Oh, come on. This one is yellow. It's yellow because this normal is in bevel. It's rotated slightly. If it hits this point ever, it should be also yellow or something. Let's try another seed. Yeah, most of the hits are green because the normal is facing forward. Sometimes it's yellow when it hits a bevel. But when I allow, for example, higher margin on top, let us see. Some of them should already hit the top. They don't. Ah, this is X, sorry. This. Yep. As you can see, this the balls on the top, they are yellow because the normal is like 45 degrees. Okay. Actually, the opposite normal will never be hit, so we should remap it. We shouldn't remap it from 0 from -1 to 1, just clamp it between 0 and 1. Now it should be better. So red will be for 90 degrees this time. Okay. Yep. As you can see, yellow is 45 degrees or so, or more like 60. Yeah. So this is red, 90 degrees. So we're interested only in those that are very close to front facing. Okay. Legomi says that you can remap dot product to radians and then to degrees. What do you mean? What is the purpose? And here I'm deleting this because we already know it's good. And we want to check whether this... Okay, maybe we... just saying. But maybe we can convert it to degrees actually. Because if you mean this is radians, so you mean that I do basically 2 degrees like this. And now, for example, I can check whether this is, I need to do the ACOS on this. ACOS. But from what to what? ACOS in radians, and then this. I would like to check whether it's a variable like maximum angle from surface. ACOS dot, okay. Maximum angle from surface. And only if this angle is smaller than this. This is what you mean? Radians to degrees. Then only then I want to say that it hit the surface. And boom. Angle on surface. Cool. Let's try. No, I think it should be the other way around, right? Because now nothing has spawned. If I just disable that. Yeah, they spawn. With this they don't, so it has to be ACOS dot degrees. I have to set it to something. Wait a second. So this maximum angle on surface now is 0. Nothing spawns. Let's do 90. Okay, they spawn. Let's do 10. 1. 0. 0.1. Cool. Perfect. So let's say that the normal has to be within 15 degrees to spawn. It won't spawn on slopes. Okay? Like so. Oh. But now it hit this point. Let's do a very narrow strip actually. Minus 0.3 to 0.3. Like so. Now we need a different random seed. Okay, now we have a problem because we lose a lot of points sometimes. Because all this has this success like variable, but you know, it happens that many points can spawn here, never touch anything. So if I want to make sure I will always have like the desired amount of decorations, I would have to do the random pick again. So in add decorations, I have this thing, decoration count 9. I should expose it as a variable actually. It's local. Where's it set? Ah, it's set here. No. Let's delete this. And let's just promote this. It should be called decoration count. And it should be editable. Okay, for the user. By default, there will be 9. Now, whenever something is not hit, I should try again. So I should do loop body while let's pack it into a function, I think. Let's pack it into a function, or no? Maybe no, or yes. Yeah, let's do it. Let's do it. It will be called, where's it? Get random point. Random decoration location. And it will be position relative to actor. Cool. And now we'll do that. If it fails to collect something, it will try again. Infinite loops incoming? No, because we will make a basically a safe break in this. So while loop, the condition would be maybe not while then. Okay, for loop with break. For loop with break and maximum tries. Promote to local variable called maximum tries. Set to 900. 1000? 100, okay. Okay, 500. Maximum tries. It will try to get a random point with a module. Now, if it succeeds here, it should go to break. Ah no, wait a second. First it has to set this position. Success should also be promoted somewhere. So local variables, success, found point, or has found point. It will be by default. Oh, it's an array. It will be set to false at the beginning. This will be promoted to local variable called found position or found location. Yeah. If it's true, then set this, and set has found point to true. Cool. And when this is done, break Okay. So that's it. So that's it. And now when it's completed, it should return whether it succeeded. Success. And give this position. Location relative to. Nodal loops are the root of all evil. Yeah, they are not pretty, unfortunately, Legomir. Unfortunately. It looks really bad, especially the direction of it. Very unclear. Whatever. That's what we have. At least we are lucky that they have loops in Blueprint. That's it. Success is whether it has found point or not. Okay? And now we have as many modules as we wanted. If maximum tries was 0, if it would be 0, then of course there would be nothing. Oh, there's still something. Ah, because it's at least one try, okay. Yeah, but if maximum tries is, let's say, this 100 or so, it will try its best to find us 9 modules. When it hits the empty space, it will find some other space. Okay? Very cool. So we have this. Yeah, the inclusive end. This is against any programming like typical structure. That normally as the end of a loop you put the one past the last element, the number of elements. Here it's number of elements minus 1. Oh no, Piatnashkin says that reverse for each loop has the index swapped from the normal order. That's insane. Oh god. Bad Blueprint. Okay, here now we have to get back our previous functionality, which is to choose the good mesh. I'd also think about adding transforms back again instead of just the rotations. Okay. Epic cannot into UX? I mean, it depends. Legomir. UX is often good in many places, but it's also like a victim of accumulation of stuff. I mean, the entire Unreal as a whole. You can see how basically stuff was added and added more and added more, and you end up with very long panels of where you can't decide what's important and what's not. They have this advanced stuff here, but I think it could be better. But in general, I find it nice, especially the UE5. Okay. We have to bring back the functionality that we were providing many meshes, these decoration meshes, and was choosing between them. So let's go back. Let's go back. And there was this decoration rotations. I will delete that thing. Yes. And I will add decoration transforms, because this time we shouldn't have this trouble that we had last time. Decoration transforms. It will be an array of transforms. And it ideally should be the same length as the array of decoration meshes. If it doesn't, we'll just use identity, the neutral transform. Okay? So add decorations, we get the points, we add the static mesh component, which is cool, but we should pick the random mesh instead of doing this. So This will go to the end. And first we pick a... You can see we have the name, the command, find a matching transform from the early try that we did on the stream before falling back to rotations due to desperation. Okay. Get random location, this is good. In a loop, it accumulates these locations. When it's done, it should do a for loop. First, picking a random mesh. What? Another sequence. Here. It picks a random mesh from the array of meshes, the random mesh type, and just sets it in a local variable. Then it finds a matching transform from the array of, not this, but the length of decoration transforms. Length. Yeah, so if the randomly picked index of the mesh type, okay, so let's do mesh type index or mesh template, one of the templates, right? So one of these, either a lamp, either a sculpture, or an ornament. It picks one of these for every point. Then if it has a transform in the array for this one, it will get it, otherwise it will use the default. So it should set randomly picked rotation should be of type transform this time. Yes. Randomly picked, or actually mesh template transform. It should set it to default or get from this array. Get reference under the index. Like so. And not randomly picks rotation, but set mesh template transfer. Okay. Jeffrey says that they're working on Substance Painter and adding anything is quite complex. They can't imagine what kind of nightmare it is to work on the whole engine. True. True. But you know, if you organize stuff into smaller pieces, I think it's manageable. Basically, anything you do, you should try to divide it into manageable chunks of work. Like, you know, split everything into tasks that you can finish in 1 or 2 weeks. Then everything becomes possible, I think, especially with experience. Okay, the best thing is not to divide and conquer, exactly like Gomit. Not to burden yourself with the whole task, with the pyramid of the whole task. Step by step by step. Basically, achieving great things through tiny steps instead of achieving tiny things with great effort. Okay, divide and conquer, exactly. Okay, still doesn't randomize. Wait, it picks up because we set the static mesh to something preset, while it should get it from randomly pick mesh, let's rename it to mesh template. Cool. Mesh template should be used here. Okay. Yep. Back to our functionality. Lamps, ornaments, and sculptures. Cool. Now do the transforms work? Let's see. We have our mesh template transforms. Here, decoration transforms. Cool. Now let's add to this array the first thing, the lamp, rotation 90 degrees, okay? 90. It doesn't work. What? 89? Load precision. Okay. Because we don't apply this yet. So we added the static mesh here. We should... yeah. What we should do is put it to a local variable again that we will call what? I can't edit the name? Why? I want. Come on. Font decoration component. Cool. I set it. Then only I will add it here. Spawn decoration component. And it should be called add to an array so that it can be deleted later when regenerating. We found it deleted later when regenerating. Okay. Then we set the static mesh to the spawn decoration component, like so. Set static mesh and now set transform. So we get this component again. Set transform. Set relative transform. Yes. And the new transform is mesh template transform. Teleport to make it instant. And that's it, I think. Let's see. Oh. I shouldn't set, I should add. Some combine transforms. Transform. Compose. So first this should be this actor, get actor transform. No. Wait, this is relative, so what? I'm getting this things transform. So get mesh spawn decoration thing. Get transform. Relative one. I'm combining it with this additional special offset. Maybe now. Not quite. This again. Wait a second. What if I just, instead of set, what if I What if I add transform? Add relative, add local transform, sure. Let's try that. Delta transform is this. And teleport. Cool. Now it works. Now these transforms here can allow me to specify rotation like this. So the lamp is normally aligned like so, and I just put rotation 45 or 90 and it works. So yeah, now it's basically an array. Like here we have an array of mesh types. We also have decoration transforms, which is an array of mesh type transforms, which also means that I can add an offset to the sculpture. Here's the sculpture, right? Let me go back here, back to defaults, and I will add more free types. Now the sculpture was the second one, so index 1. Now check, if I rotate it, it rotates, okay? So I want to add some subtle offset, maybe, or don't. Yeah, these guys are pretty well aligned, I think. For the lamp, yeah, it's also cool. It's also cool. You know, for an ideal solution, you can pick not just one point, but many points, and check if all of them together are okay with the rules that we set, the surface and everything. Here we just pick the one point, the pivot. So if the pivot is okay, then it thinks that everything is okay. So we can make it more like sophisticated. But this will suffice for now, I say. See, here you could also check, for example, 4 corners of this mesh or something. I'm checking just the pivot. But for now it's okay. Let's check if scale will work. If I do scale like this, yeah, yep, it does. It does. Cool. Very good. Very good. Legomir, this is French. What does it mean in English? The last word is bread. Okay, cool. Now, everything we do within the module, right? So we don't have more modules. Packard is a pain. No. Pain or pan is bread. So, as you can see, more modules are spawned, but everything in the same spot, right? Because we decided to move to the module space with all this, but that's good. That's really good. This is what we wanted. Now we will try to move the whole thing, the decorations, transformed already, rotated. Now we can move them together. It should also work fine with rotation. Let's try. Yep, rotates like a charm this time. If you remember the panes from the previous part, this is perfect. Okay. Conquest of bread. Okay. Legomir, is it a communist book, maybe? Anarchist book. Yep. Yep. Okay, so now what we try to do is to move the modules Okay. Let's delete all this. Oh, we forgot about one thing. Our anti-decoration volumes. Anti-decoration volumes. It should be checked. So when picking this random point, we should also check whether this thing is within such a volume. But this is problematic, you know. No, it's in a good spot. It's in a good spot because if we move the volume, then it should check if it's in the right place. Okay. So after doing all this, do we have the components? New decoration components. Does it add? It adds unique to spawn decorations. To spawn decorations. Okay, so this won't be needed here. Nope. This anti-decoration volumes, we'll return to it. This won't be needed then. And this wall extends Y. No longer needed. Is it something like clear unused or something? I guess no. Mesh template index, is it used? It's in use, okay. Decoration location word. Ah, yeah, here. Sure. Wait a second. But where is it set? Ah, here. Okay. New decoration components, what's that? It's in use. Find reference. Uh-oh, nope. Spawned decoration components. Spawn decorations, it's called. Ah, I see. I see. Add spawn decoration to an array so that they can be found. Let's move this here as the almost last step, like so. Oh, come on. Like so. Okay. Okay. Now what's going on here? I'm setting a static mesh, adding transform. Cool. Wait a second, what's going on? I'm adding a static mesh, which is happening there. Setting static mesh here. Adding location here. Yeah. New decoration components. I should add to it. Like so. And on the end, I would just add everything. So this, add items. Oh, what? Okay, so does add unique, does it accept this. Uh-oh. Containers of containers are not support. Oh my. Oh my. So for each of these dudes, add them to spawned components. Cool. And return new decoration components. Perfect. Perfect. Append is the term, but it's not unique, so not add, but append array. Oh, thank you. Piatnashkin, you're giving me so many great tips. So many great tips. I don't need that. I just append to the array. Perfect. Thanks so much. Thanks so much. Like this. It's good, I think. It's coming together. The goal for now is achieved. Things are placed on the surface. Despite the very complex mesh, they are not spawned in the empty space and not on the bevels. Now what we need is moving this stuff. So we have our reference to the spawn decorations here. Add decorations, we have them. And now what we can do is to move it together with the module. So okay, we're adding an instance. And now we should set instance transform after we're done. We should move the module. So I'm getting this instance group wall, set transform, set instance transform, or something like that. Set instance. It isn't. No, there was. Instance group wall, instance. Update instance transform, okay. Okay. There is something called mark render state dirty. It tells Unreal that it should refresh the graphics now. So normally when you're dealing with hundreds of instances or thousands, you would like to keep this off, despite the very last instance where you want to have this on. So when you're done, you only tell it to refresh the graphics. But here I will just enable that because I don't know, which module it is. So I'll just enable that. Piatnashkin says they remembered it from my video. Thank you. Yeah. Video. I recommend it on techart8.com. It's somewhere here. Optimization instancing. Explained there. Okay. By the way, guys, on the products page on techart8.com, you can find asset files from YouTube tutorials. So basically, this is this asteroid field that you can experiment with. I've also upgraded them for Unreal Engine 5. So you can find them already upgraded, containing this asteroid asset done with instancing. Yeah. Paid package, but I hope it's worth it. Okay, so we update instance transform. The new transform should be created from scratch. Make. But is it local? I hope so. Workspace tick. It's off. That's good. I'll make transform with location being my mesh length my mesh length times the number, the index of the current module. So this is my x-axis location. Make vector x-axis location. Mesh length. Now rotation and scale remain what they are, okay? So now the modules should move towards this point. Let's see. They do. Awesome. Awesome. Now we take this point. Uh-oh. Hold on a second. That's not what I wanted. There are only two modules. Mesh length times instance index. Is it connected? Ah, mesh length is not. Oh my god. What's that? Mesh length is not connected. Yeah. And scale. We can also make scale by using scale to match end. So how much we have to scale the module to fill the gaps. Okay. We add this. Ah, instance index. Sorry. This guy. Okay. So we're updating the transform of this given instance with the length of the mesh multiplied by the index. What? It vanished? Ah, scale is 0. Okay. Cool. We have it. So let's see. Let's see. Not quite. Not quite. But almost. Almost. The location has to be scaled as well, probably. Location has to be scaled, oh my god. So this multiplied by this. Okay, yeah, perfect. See? So I have to multiply the location as well by the scale to match end and see what happens now. I move the stuff and it just perfectly scales towards this point. Always filling, okay, almost filling the gaps, but this is due to bounds of this mesh. It's easy solvable, but not now. Let's not complicate the code. Beautiful. Thank you. Thank you. Okay, we got this. Now we have to move the decorations. Because as you can see, scaling the mesh leaves the position where it was. So we would like to scale them also, their location, to match this thing. So we have that. Soviet buildings. Yeah, that's kind of like social realist architecture. Or just classic, you know, it depends. This was inspired by classicists. This is actually funny how Soviet architecture was inspired by the bourgeoisie. Okay, we have return node. And this we have to say to delete. Cool. Okay, so now scaling the position of the instances of the decorations. I'm adding decorations. I have their components, which I can store somewhere in local variable. Decoration components. Cool. Piatnashkin asks, can you attach the whole array of modules decorations to the modules scene component before transforming, so they transform for free? I can't, because the module is not a component, it's an instance. So I can't attach to instances, unfortunately. They are rendered only on the GPU. That's why they are so cheap, but they don't exist in Unreal's, like, you know, view of the world. They're just virtual. There's another reason. I would like to move them, these decorations, but not scale them. So I would like to only scale their transform location. But thanks for asking, sure. I really appreciate your comments, very helpful. I learned a ton. So for each decoration, I also want to use the same thing. Okay, so let's do... okay, let's store it in a variable, as usually. Or store it in a transform. Store it in a transform as local variable. And it will be module transform. This particular modules transform. Okay, and I want to take this modules transform, break it, and for the mesh, add local transform for the decoration, right? What is the difference between add local transform and add relative transform? Local is maybe within its own rotation of the component. Okay, I don't want that. Relative to its parent, that's better. That's what I want. Exactly, that was the problem the last time. You know, if the mesh is rotated, I want it still to move within the blueprint's space, not its own. Okay, so add relative location, and it will be module location, I guess. Module beginning location. But first I want to scale its local location. So first I want to set get relative location to its parent. I want to get this. I want to multiply by the scale of the module, you know, to stretch them within the module space. And then I want to add this module's pivot in the corner. Okay, so kind of complicated, but I think it makes sense. First, I want to scale them to the module itself, and then move them together with the module. So like this, relative times scale plus location of the module's pivot. This is my delta, the difference of the location. Let's see, teleport, of course, to not detect physics. Let's see. Did it help? It didn't. It didn't, because I have module trans... Oh my god. This is within the same loop or no? It is. I have instance index. For each decoration within that module, I want to move them. So what's the problem? What's the problem? They don't move, basically. They just spawn there. Did I connect everything? Sequence order is right, Piatnashkin asks, so sequence order. First, it sets this module transform variable from this thing, updates the instance transform using it. That's cool, that works. And then the for each loop is after this one. Yeah, it is. It is. So for each decoration, it gets this module transform location, delta. That's weird. That shouldn't be 0. I wonder what's relative in that regard. Let's print it out. Print this. It doesn't happen? What? Oh, this is empty. What the hell? Decoration components, not spawn decorations. Decoration components. Yay. Not quite. Not quite, but this is something, you know. But yeah, we're not quite there. But this is already something. So module transform location. What's wrong what's wrong here, Adder? Not quite, but almost, exactly. That's the thing I can't say at work where they pay me. Unfortunately. What's wrong about them, to be honest? Maybe if I don't add this scale for now, just for now, you know, to test. What's going on? Why they are so contracted? You're so tired, so you're barely sitting. Okay, you can go, you know, go get some sleep, because I'll be finishing soon, by the way. I just want to get this to work. Huh. And thanks, Adel, of course, for being here. I know this is late hour for you, so feel free to go. What's going on? Relative location. Relative to what? What if I just take this, add location? What does it propose? There's also local and word and word. There's also add local offset in its local reference frame and relative location. Okay, thank you. Set relative location. Because I'm getting my own location first of this component. Set will be better than add. Okay. Now it should be good. Set, not add. I've combined the same transform twice. Yay! We get it. We got this. So now they are transformed. I don't know if correctly or not. Let's try removing to check. Kinda scaled, sure. Ah, wait, there's one small problem. I don't know how severe, but basically we test against a non-scaled module, which we later scale. And this positions They are not longer tested against it. So we could add the scale on the very beginning, I guess. When we add the instance of the module, we can already set the correct scale. So let me take, where's the scale? Here. We can already set the correct scale. And later we can just get this. So get group wall, get transform, instance index this. Scale from the existing thing. Cool. Yep, now they fit. Because, you know, we should scale this before we cast rays. Do not scale. I want to scale. I want to scale. I'm generally against scaling, but in this example, I wanted to so perfectly match this point. Okay? I wanted to perfectly match this point. It's beautiful when it happens. And no matter how many modules, it always ends at this last instance end. I think the effect is worth scaling. But yeah, in general, guys, avoid scale if you don't want trouble. It's better to scale the source mesh. Oh, hold on. Hold on. It didn't end well. No, it's, yeah, we should, yeah, I was mistaken. We should cast against the original because we scale both later. So no worries, cast against the original. Yeah. And instead of getting this stuff, just make from the mesh and scale. Like we did before. Sorry for the confusion. Because we should trace against the original because we then scale both decorations and this thing. So yeah, back to this here. And here just use the neutral identity scale 1. Cool. So we have it, guys. Let's place some more. Oh, the connectors. Come on. The connectors. They should also be moved. So update instance transform of this dude and also of the connectors. The number of them is the same. So we can use the same instance index. New instance transform can be, I think, the same. Or no? No, not the same. Almost the same. So split, break, almost the same, with the exception of custom scale. Of custom scale, okay. And rotation. Render state dirty, yes. Teleport, yes. Like so. Okay. So now also the connectors move. Okay, they do. They do, as you can see. Okay, we should have one more connector than we have these. That could be a problem, actually. Okay, let's not do it right now. Let's not do it. And here we should call it move decorations and spread them to fit the given module. or together with the given module. Together. Legomil says this is similar to the Qt application UI that he's working on, when you have to set a layout of an application and then scale stuff dynamically. Yeah, I get it, I feel it. Okay guys, we have this. Let's put some level. This dude, okay, he can stay here. This. Whoop, transfer. Wait a second. First, the length of this could be... I don't know how big this mesh is. Let me check. It's 3 meters. Okay. So 3 meters can be like this. 0. Copy. Rotate. As you can see, the decorations stay in place, which is brilliant compared to our first time from the previous part. Okay, I will reverse them because it will be like an interior, okay? Like this. Oh. Okay. Cool. Perfect. Now we can do 2 floors of this. So like that. But now I can copy them. Can move them higher. Cool. And now I can actually move this one by 1 unit here. This one by 1 unit here. And do 1,500 or 1,800. Cool. Legomil, you posted something on the chat, but I think links are disabled. Or no? Are you a follower on Twitch? If yes, then you can post links, I think. Okay. So... oh, Legomil is now following. Awesome. 1,800. So as you can see, I'm basically adding this stuff. And the whole beauty of it is that it's not based on the number of instances, it's only based on this point, right? So I can replace that. I can take and replace that with whatever I want. For example, this. And it fits the same length. Okay, that's the beauty of it. I can take medieval wall, or I can take this, and it just copied the thing so many times because it's just a small pillar, like so, but it copied it as many times enough to fit the length towards this vector. So super universal what we achieved here. Super universal. Let me try this because it was nice. Actually, I make it shorter. I'll make it 600. Then do one more with a different mesh, but just 300. Okay. and another 300 with this mesh again. Cool. So yeah, we have that. More length. And we're good to go. I think I will replace this in the same fashion later. Let's do it already. Let's do it 300. Then with another module. Copy. And 600. Okay. With module like so. Would there be a way to keep the textile density in check? Jeffrey, I think it depends on the materials, because if you change the mesh, the material density will be different, but of course the scaling, it's not so aggressive. Take a look, because when I move it, this thing, this is the maximum scale, 1.5. So sure, you could do a material that procedurally generates UVs for this, independent of the object scale. You would like to see the word position video and use the same stuff to generate UVs based on position. But in general, I think you shouldn't worry too much, because as I said, 1.5 is maximum stretch here. Yeah, deploy custom primitive data. You can deploy custom primitive data from this interactive materials, and you can also do this word position effects. Give me a moment. Dynamic UV projection, it's here. So I recommend that video. Okay, and here what I could also do, give me a moment. This is okay. I should do some floors like this. Okay, this may serve. I know it's shitty a little. I just use a random asset, right? But it shouldn't matter that much for now. What I want to do, and it will be at the end of this session, is to make a ceiling and a floor out of this, okay? So let me add that, let me rotate that, like so. Okay. Scale it a little. I know no scaling, but forgive me. Like so. Now I would like to snap that to something, but whatever. Transform snapping 10. Like this, I guess. I could theoretically use the same thing. Okay, let's try. Let's try. 50. Let's try using the same thing. I will just copy this over. I will delete any decorations. I don't want them. Mesh connector, can I use empty? And then shrine stone floor. Awesome. I would like to have a way to scale it, by the way. Because it's based on extents. It's technically an art. It's technically an art. I would like, you know, to kind of change this extents Oh god. Okay, let's add it. Let's add a scale to this instance of the wall. Scale XYZ, so multiplied by wait, that's wrong. It shouldn't be like this. Yeah. We shouldn't be adding scale of the module. We should be adding the same stuff that was used to calculate the scale of the module. Like this. What? Wait a second. No. Scale. Yeah, I think it was good. Basically this mesh scale. Mesh and scale. Like this. Move decorations and spread them. Does it still work? It works, okay. Okay. So now what I want to do is to add a special local scale to these modules to make them fit together. So times, and let me add a variable, editable variable, module scale or module extra scale. Get, by default it will be 1, scaling the thing like so, I guess. Does it work? It didn't break anything, at least. Yay! It does. Okay, so we're good to go. We're good to go. So we have this. Does it scale in place? Yes. Perfect. Now my endpoint should be a little further. Cool. But why doesn't it match this endpoint now? Is it caused by the scale? Ah, it's caused by the pivot of this thing. It begins earlier than it should. Oh my. Okay, so we should add the mesh pivot to this, but let's not bother now. Let's not bother now. 115. Cool. We have that. Okay, not quite yet. Whatever. Connector. Why are you here? This is set to none. What? Why does it spawn pillars? I specifically set it to none. Okay, I know what I should do. I should do that if this doesn't exist, I shouldn't spawn. So connector only if there is anything. So I should do in construction script in the initialize set static mesh connector, and then I should do disable this if the mesh is invalid. So mesh module, no, mesh connector is valid. If not, wait, is valid. And now, if it's not valid, I should hide this. So disable, wait, set enabled, set active, to false, or rather is valid, set to is valid. Reset, what's reset? I don't know. Maybe yes. Does it make sense? Random tip number 345 from Piatnashkin. You can convert getters to validated getters with right click. So this? How? Convert to validated get. Ah! Wow, thanks. Cool. Okay, so I will disable this, you know, these pillars when the mesh is not provided, okay? Let's see. Let's see. Now if I copy this over, the pillars returned. Super weird. Okay, but when I just do clear, it's good. Oh, they are too high. But look at the efficiency. Now I can just select them and just move the thing without any hassle. I just have 4 objects to select, okay? Okay, I get this. Rotate. Shorter last instance. Cool. And now duplicate this as well. Okay, great. I select those, I disable the posts. Clear. And we're good to go, I think. Oh, the steps. Oh my god.